equation number 10. So once we solve for time path of price, once we get this equation, as you know, the next step will be to analyze the stability of this model, whether the equilibrium is stable or not. That is whether the time path is convergent or divergent, number one. Number two, whether the time path is monotonic, whether the time path is oscillatory. So this kind of analysis we have to do. Now, look at the equation. Equilibrium will be dynamically stable if Pt tends to Pe as T tends to infinity. Everybody? Equilibrium. I hope everybody has pen and paper with you. Okay, so whenever there is a kind of thing that you have to do something, solve something, or take a note, please do so. So, equilibrium will be dynamically stable if Pt tends to Pe as T tends to infinity. So, if I put this condition as the stability condition, we need that the other parts should tend towards 0 as T tends to infinity. This part, this first term in the right-hand side, should tend towards 0 as T tends to infinity. Now, from our previous experience of first order difference equation, we know that this P naught minus Pe is a constant. It is just like the a b to the power t. So it is a, P naught minus Pe. And this is nothing but the difference between the initial price and the equilibrium price. Both initial price and equilibrium price, sorry, these two things are given to us. Both the initial price as well as the equilibrium price, these two things are constant. These are given to us. So their difference is also a constant. So the difference P naught minus Pe, this part is a constant. So if we want that as T tends to infinity, this factor, this entire factor tends towards 0, what will be the condition? What will be the requirement? Anyone? P naught minus Pe is a constant. However, we want that entire product, P naught minus P into beta 1 by beta 2 to the power T, should tend towards 0 as T tends to infinity. So what will be the condition? What is the requirement? How this term can move towards 0 as T tends to infinity?
Beta 2 greater than beta 1.
T equals to infinity.
Okay, very good. Actually, what you want to say, modulus beta 1 by beta 2 less than 1. Am I right?
Yes, ma'am.
Yes, ma'am.
Modulus beta 1 by beta 2 should be less than 1. Okay. So in general also, when we discussed about stability, etc., we got the condition in the factor a b to the power t, mod b should be less than 1. This is the requirement of the stability. So here we are getting the same thing, because this is an application of the first order difference equation. So while we are applying it in context of market economics, considering a lagged adjustment model, where lag we consider in terms of the supply phenomenon, not with respect to demand phenomenon, we are finding that the required stability condition is mod beta 1 by beta 2 should be less than 1. Modulus of beta 1 by beta 2 should be less than 1. Now, if you go back, what are these beta 1 and beta 2? Beta 1 is the slope of the supply equation. Beta 2 is the slope of the demand equation. Okay. So the condition or the requirement is, the absolute value of the slope of the demand. Sorry, I think beta 1 is the slope of the supply, isn't it? Yeah.
Yes, ma'am.
slope of the supply divided by slope of the demand, that is less than 1. Okay, absolute value of the gradient of the supply equation divided by gradient of the demand equation, that is less than 1. So this is the required condition for stability. So hence the condition of stability is given by mod beta 1 by beta 2 is less than 1 given P naught minus PE is a constant. So this is the required stability condition. Okay, this is the required stability condition. Okay, later when we will do the graphical analysis, we will once again check whether really we are getting this condition or not. And while we will plot the graphs, remember we will plot the inverse demand as well as inverse supply functions. Okay, already you are aware of these things from your first semester learning, that when we plot the demand curves and the supply curves, we consider the inverse demand as well as inverse supply curves. From here we are getting the absolute slope of the supply is less than absolute slope of the demand. However, to match the thing, when we will go for the graph, we have to consider 1 upon beta 1, 1 upon beta 2, etc. Otherwise, there will be a mismatch between the mathematics and the graph, because here we are considering the reverse axis. While we are plotting price and quantity, we are considering reverse axis. Okay, so basically we are considering the inverse demand as well as inverse supply curve. So when we will plot these things, we will come back to these slopes condition, slope related matter. Okay, however, if we consider the theoretical matter, I hope everybody is agreeing that the stability condition in a curve wave framework is given by mod beta 1 by beta 2 is less than 1. Is it understandable? Are you accepting this as the stability condition?
Yes, ma'am.
No doubt? Everything is fine?
Ma'am, could you please show the previous slide?
Yes. You have the equation P naught minus P beta 1 by beta 2 to the power t should move towards 0 as t tends to infinity. This is the requirement. Given P naught minus PE a constant, this entire term can move towards 0 if mod beta 1 by beta 2 is less than 1. So mod beta 1 by beta 2 less than 1 is appearing as the stability condition of this dynamic equilibrium. Another thing want to know, what will be the nature of the time path, whether it will be monotonic, whether it will be oscillatory. If the ratio beta 1 by beta 2 is less than 0, the time path will be oscillatory, So if we go back to equation number 10, if this term is negative for even values of t, this value will be positive. And for odd values of the t, this entire value will be negative. For even, it will be positive. For odd, it will be negative. Okay, for example, or to understand the matter in a better way, let's consider both beta 1 and beta 2 are positive. The values of beta 1 and beta 2 are positive, okay? So if you get minus beta 1 by beta 2, minus beta 1 by beta 2, that indicates really the value is negative. In that case, if your power is 1, it will be negative, 2 positive, 3 negative, 4 positive, 5 negative, 6 positive. So it will go on like that. Okay. So if there is this equilibrium price PE, okay, PT will continuously move up and down this value.
Ma'am, can you repeat this, please?
Yeah. I just didn't complete. Okay, there is no question of repetition. I'm just telling you the things. Look at this equation. Look at this equation. Look at the right hand side. There is a constant term. Second term is PE, the equilibrium price. PE is the equilibrium price. Now, if beta 1 by beta 2, or this ratio is negative, what I am telling that for even and odd power, you will get positive and negative values. For even power, you will get positive value. For the odd power, you will get negative value. Okay? So, this entire thing, or PT, the time path or the left-hand side variable, will continuously move up and down the equilibrium. For the even value of t, it will move up. For the odd value of t, it will move down. Okay, so it will continuously move up and down the equilibrium. This is a positive value. PE is the equilibrium price. Generally, it will be a positive value. PE will be positive. The minimum value of PE is equal to 0. The minimum value of PE is equal to 0. However, generally PE will be positive. It can be the least value is 0. Okay, so what will happen? This PT will move up and down around the equilibrium continuously depending on even or odd value of t when this ratio beta 1 by beta 2 is negative, or this entire element, small b. In general equation, it is small b. So if this small b is negative, your time path will move up and down around the equilibrium continuously. So you will get an oscillatory time path of price. You will get oscillations around the mean value. You will get oscillations around PE. Your PT will move up and move down. So you will get oscillations around the fixed value or around the constant value PE, which is your equilibrium price, which is your market clearing price. Okay, so price will move up and down around the equilibrium price. Now, it may happen that when you are getting this kind of oscillations and you are getting this kind of movement around PE, over time, you are coming continuously very close towards PE. In that case, actually the oscillations will be damped oscillations. What I am telling that when you are getting this kind of movement up and down the equilibrium, it may happen that when you are getting up and down, up and down, up and down, over time, these prices are moving very close towards equilibrium price PE. So in that case, your equilibrium is dynamically stable. So oscillations are there, however, these are dynamically stable. So together the two condition gives damped oscillations, damped oscillations. However, when you are getting this kind of oscillations, it may happen that you are continuously moving away and away from the equilibrium price. So both the up price and the down price, these are moving away and away from the equilibrium. So in that case, you are getting oscillations. However, these oscillations are explosive oscillations, explosive oscillations. The third possibility, when the price is moving up and down, it may happen that it is moving up to a certain level, a particular level. And again, it is moving down to a particular level. Up a particular level, down a particular level. Neither converging to a equilibrium, nor diverging from the equilibrium. When it is going up, it is moving at a particular level. When it is going down, it is moving at a particular level. So if this kind of thing happens regarding PT, in that case, it is uniform oscillation. Okay. Never it will move towards equilibrium, never it will go away and away from the equilibrium. Okay. So we will discuss all these possibilities. Remember that if beta 1 by beta 2 is negative, always you will get oscillation. If it is negative, you will get oscillation. Okay. Beta 1 by beta 2 may be positive. Beta 1 by beta 2 may be positive. Your B value may be positive. In that case, as power increases from 1 to 2 to 3 and move towards infinity, this value remains positive. This value remains positive. It's not that it is negative, then positive, then negative, then positive. It's not like that. It will remain positive. Okay, it will remain positive both for the even as well as for the odd orders. So in that case, you will get monotonic time path. You will get monotonic time path. So if this ratio is positive, you will not get fluctuations around the mean. Rather, you will get either path is moving towards equilibrium or moving away from the equilibrium. Okay. So it can be monotonic convergent, it can be monotonic divergent. However, the path will be monotonic in nature if beta 1 by beta 2 is positive. So here, if you look at the thing, beta 1 by beta 2 negative indicates time path is oscillatory. Why oscillatory? Because then for the even power, you are getting positive value. For the odd power, you are getting negative value. So it is coming down to the equilibrium, moving up to the equilibrium. Next, when beta 1 by beta 2 is greater than 0, time path is monotonic. Time path is monotonic. Is there any question regarding the oscillatory and monotonic nature of the time path? Is it okay to all of you?
Yes, ma'am.
Yes, ma'am.
Okay, fantastic. So now we will combine the conditions, beta 1 by beta 2 less than 0 and mod beta 1 by beta 2 less than 1. If this is the thing, you will get damped oscillation. If we find beta 1 by mod beta 1 by beta 2 greater than 1, however, beta 1 by beta 2 is negative, in that case, we will get explosive oscillations. If we find mod beta 1 by beta 2 equal to 1, however, this value is negative, in that case, we will get uniform oscillation. Actually, this value is -1 then. If you get the value beta 1 by beta 2 is -1, in that case, mod value is equal to 1. However, the ratio beta 1 by beta 2 is negative. So in that case, you will get oscillation. However, it will be uniform oscillations. Okay. Next, we will consider beta 1 by beta 2 greater than 0, and we will consider mod beta 1 by beta 2 greater than 1, mod beta 1 by beta 2 less than 1. If mod beta 1 by beta 2 is less than 1 and it is positive, you will get monotonic convergent time path. If mod beta 1 by beta 2 is greater than 1 and beta 1 by beta 2 is greater than 0, in that case, you will get monotonic divergent time path. Okay, and if beta 1 by beta 2 is +1, in that case, you will get a time path which is parallel to the horizontal axis at the value 1. Okay, so already I think you are quite familiar with all these graphs, So, you know, you will get all these varieties for the cobweb model. So we have to understand how we can generate all these varieties of the time path in context of cobweb model. Okay, so all these cases we need to cover. Case 1, beta 1 greater than 0, beta 2 less than 0. That means supply is positively sloped, demand is negatively sloped. The usual case, beta 1 is the slope of the supply curve. So supply curve is positively sloped, demand curve is negatively sloped, and mod beta 1 less than mod beta 2, or mod beta 1 by beta 2 less than 1, mod beta 1 by beta 2 less than 1. So we will get damped oscillatory time path of price. Beta 1 greater than 0, beta 2 less than 0. So I'm not changing the first condition, that is supply curve is positively sloped, demand curve is negatively sloped. However, mod beta 1 greater than mod beta 2, that is mod beta 1 by beta 2 greater than 1. In that case, you will get explosive oscillations. Beta 1 positive, demand curve is negatively sloped, supply curve is positively sloped, mod beta 1 exactly equal to mod beta 2, you will get uniform oscillation. Or mod beta 1 by beta 2 is equal to 1, you will get uniform oscillations. Next, both the demand and supply curves may be negatively sloped. Okay, that is beta 1 by beta 2 is positive. Okay, so when beta 1 by beta 2 is positive, however, mod beta 1 by beta 2 is less than 1, you will get monotonic convergent time path. Finally, both demand and supply curves negatively sloped. However, mod beta 1 is greater than mod beta 2, that is mod beta 1 by beta 2 greater than 1, we will get monotonic divergent time path. We can extend the analysis considering both the demand and supply curves are positively sloped. Okay, and then mod beta 1 less than mod beta 2, mod beta 1 greater than mod beta 2. So we can go on like this and check all possibilities. Okay, what will be the nature of the time path for all these varieties? Demand negatively sloped, supply positively sloped, both demand and supply negatively sloped, both demand and supply positively sloped, etc. Okay, and the gradient value we are changing, mod beta 1 sometimes less than mod beta 2, mod beta 1 sometimes greater than mod beta 2, mod beta 1 sometimes equal to mod beta 2, etc. So we can change the gradient of the demand and the supply curves, we can change the slope of the demand and supply curves, and check all kinds of possibilities, or how we can generate the time path, or what will be the nature of the time path for all these cases. Any question?
Ma'am,
Yes.
beta 1 over beta 2 is equal to 1. Won't the time path be horizontal?
You are telling that mod beta 1 is equal to mod beta 2.
Yes.
Okay. If you find that beta 1 greater than 0, beta 2 less than 0, that is sign of the slopes of the demand and supply curves are varying, in that case, you will get oscillations around the mean value, because your beta 1 by beta 2 is negative. If beta 1 is positive, beta 2 is less than 0. In that case, beta 1 by beta 2, this thing is negative. And whenever this beta 1 by beta 2 is negative, if you consider the even power, odd power, it will fluctuate around the mean. However, since mod beta 1 by beta 2 is equal to 1, when you are considering this fluctuation, it is moving within the band +1 and -1. Okay, mod beta 1 by beta 2 equal to 1. That means your beta 1 by beta 2 is varying between -1 to +1. Are you getting my point?
Yes, ma'am.
Okay, so it will move to minus value and it will move to plus value, minus value, plus value. However, this value will remain unchanged. Okay, so you will have uniform oscillations.
Yes, ma'am. Thank you.
Anyone else? Any other question? So in the next step, just a minute.
Ma'am,
Yes.
ma'am, I just wanted to ask what will be the case if both beta 1 and beta 2 are positive and mod of beta 1 is less than mod of beta 2?
Beta 1 and beta 2 positive.
Yeah,
Yes.
and mod of beta 1 is less than beta 2, then what will be the time path be like?
You tell me when mod beta 1 by beta 2 is less than 1, whether it will be convergent or divergent.
Yes, ma'am, what do you ask?
You are telling mod beta 1 is less than mod beta 2.
Yes, ma'am.
So mod beta 1 by beta 2 is less
Less
than
than 1.
1. Less than 1.
Yes. Yes,
So
yes, yes.
when
Then it
mod
will be convergent.
monotonic convergent.
Yeah,
Yes.
yeah. Thank you.
Okay, so one by one, we have to discuss the cases. So first, please note down these things because you have to draw the diagrams on your own. So let's start with case 1. Okay, case 1. Beta 1 greater than 0, beta 2 less than 0. Okay, so supply curve is positively sloped, demand curve is negatively sloped. Okay, and modulus of beta 1 by beta 2 is less than 1. Modulus of beta 1 by beta 2 is less than 1. So I hope you gave the heading. Okay. So I'll show you how to draw the diagram. Just check the thing, how it will look like, etc. So here the demand curve is negatively sloped, supply curve is positively sloped. Now, when the two curves follow two types of slopes, it is very difficult to understand which one is steeper, which one is flatter. Okay, so we will make some kind of back calculation so that we get the required result. However, there will be no issue like this when both the curves will be negatively sloped or both the curves will be positively sloped. Okay. So here, if you look at the thing, our first price level is this one, So we are starting with this quantity demanded and suppose the market price is this one. So if this is the market price, what we are getting, excess demand or excess supply? Price at the first price, what we are getting?
Excess
Excess
supply.
supply.
What will be the market mechanism? A reduction in price or increase in price?
Reduction.
Reduction.
Right.
Reduction. So price will fall. In the next time period, price will fall. If it is the first period price, since there is an excess supply, in the next period, price will fall. Okay. Now, when price is falling, it is falling to the level which is below the equilibrium price. Why? Because here one curve is following negative slope and another curve is following positive slope. So when we will move from period 2, say period 3 price will come down to the equilibrium level. Now in period 3, what is the position? Excess demand or excess supply?
Excess demand.
Excess demand.
Excess demand.
Mechanism will be price will go
Up.
up. Price is going up. Next period price. This is the next period price. Price is going, sorry, this is the next period price. So price is going up. However, it should be above the equilibrium price, PE. Excess supply, so in the next period price will go down. When the price is going down, it is coming below the equilibrium level. Excess demand, price will go up. When price is going up, we are getting this kind of excess supply. Okay. I hope you are understanding. Again, it will fall at this level, excess demand. So it will go up to this level. Again, there will be excess supply. So it will move like this. And finally, there is a chance that this path is moving at the equilibrium price, PE. Is it understandable? Price is, when we are getting this kind of price spiral, it is moving towards the equilibrium price. Not understandable?
No, ma'am,
Yes,
understood.
ma'am. Yes, ma'am, understood.
Yes, ma'am.
Understood? Okay. So if I plot the time path of price only, we will get damped oscillatory time path of price like this. Okay. I have started from this price which is above the equilibrium, then coming down, coming up, down, up, etc. Along this direction, we are measuring T. This is the equilibrium price PE. And the path of price is moving around this equilibrium price PE. And it is continuously, I have put an arrow here because further it will move up and down as T tends to infinity. Finally, it will merge with the equilibrium price. Asymptotically, it will merge with the equilibrium price. So you got some idea about the cobweb model? How you have to draw the things, how you have to find out the time path. Getting some idea? Yes or no?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes.
Yes, ma'am.
Okay, so now I'll draw the thing in front of you. Okay. So this is the demand equation. So everybody, I hope, could complete up to this. You consider two axes, price axis, quantity axis, and draw the demand curve. Then instead of drawing the supply curve, I am considering a particular quantity. Because as I mentioned, it is difficult to understand which one is steeper, which one is flatter, if one slope is positive, one slope is negative. So better to consider the back calculation. So I am considering the first period price. I'm considering the second period price. While I am considering the second period price, I extended the price line up to this so that I can create a spiral inside, or create the movement inside. When we will need divergent time path, I'll extend this line beyond the first quantity. When I need the uniform movement, I'll come up to this, okay, and lock the movement in this zone. Here, first, I want to consider the case where demand and supply curves are following negative and positive slopes, and I want to find out damped oscillations. So I am considering the movement up to this and then bringing the price up to the demand curve. Once I get this particular box, joining these 2 points, I'll draw the supply curve first, and then I'll consider rest of the movements. So I'm joining these 2 points. And getting the supply curve. Everybody could complete up to this?
Yes, ma'am.
Yes, ma'am.
Fantastic. So next we will consider movements of the prices up and down. So I hope everybody could do it and generate the cobweb. Okay. And finally, it will go on and on. So I'll stop here and consider an arrow and put the arrow here, which means it will again move and move and move. I'm also marking the marking the equilibrium price. This is PE, and if you like, you can also put some arrows here. To show the direction of the movement. And so on. So everybody could do this thing? Anyone, any problem? Any part I need to clarify?
Ma'am, can you explain that why it is traveling horizontally, that part once again, like the structure once more?
Horizontally means? I didn't get you.
Ma'am, horizontally you said that there is an excess supply, right? So but in that line, like the horizontal red line portion, the price isn't changing, right? The quantity that is being demanded and the supply is being different because there's excess supply. So I can't understand that how is price changing at that point.
Okay. So I hope you are understanding this is the quantity demanded. Look at the diagram. So this is the demand curve. So I hope you are understanding this is quantity demanded. This first quantity is there. This is quantity demanded, you are understanding?
Yes, ma'am.
Because I have extended the line up to the demand curve. Okay. Next, if you consider this, then I am drawing the price line. Okay. Now, if this is the market price and if this is the demand at this price, what is the supply at this price? That is given by this line, this line. At this price, the supply is given by this, isn't it?
Yes, ma'am.
So there is a gap between demand and supply.
Yes, ma'am.
That is nothing but excess supply. Okay. If there is an excess supply, what will be the direction of movement of price? If there is an excess supply, what will be the direction of movement of price?
Price will decrease.
Price will decrease. Very good. So this is the first stage. This is the demand, this is the supply, this is the price. There is an excess supply. We are understanding price will come down. Now, because of the nature of beta 1 by beta 2, when it will come down, it will come below the equilibrium because mod beta 1 by beta 2, because beta 1 by beta 2, that is less than 0. So if beta 1 by beta 2 is less than 0, for the even period, it will be in the positive direction of PE. For the odd period, it will be in the negative direction of PE. So when the price is falling, it is falling below the equilibrium. Is this point clear?
Yes, ma'am. Yes, ma'am. I understood now. Thank you.
Okay, I'm telling one more thing. Now with the second price, if this is the price, this is the price, this is the second price. In the second price, this is the supply and this is the demand. In the second price, this is the demand and this is the supply. So there is excess demand or excess supply?
Excess demand.
There's excess demand.
So price will go up. So when price is going up, it is moving up the equilibrium. So this is the third price. This price is the third price. Now with this third price, demand is here and supply is here. Okay. So still this is the demand. This is the demand. However, this is the supply. There is an excess supply, so price will come down. So this will be the fourth price. This will remain the supply and the demand will fall. Sorry, the demand will increase to this level. Okay. So there is an excess demand, price will go up. So I didn't extend the quantity parts because it makes the diagram very untidy. Therefore, quantity I marked, by these amounts only. However, for understanding purpose, you may drop down the quantity parts so that all these things become clear to all of you. So if you like, you can use this color. You can drop down all these quantities we have considered. and you will understand the excess demand, excess supply positions more clearly. So if you like, you can drop down, and that you can use the dotted lines like this. Okay. So make these dotted lines so that you understand.
Ma'am, is it compulsory? Otherwise, it'll look very dirty.
Yeah, that I told you. However, for the first time, if some students feels that this is better understandable, okay, no problem. No problem. Okay. I think some of the students felt that we are considering price. However, we are talking about excess demand, excess supply. So where the quantities are, okay, all the vertical lines are quantities, all the horizontal lines are basically prices. So that's the mechanism. Okay. So when you will practice, you will not need all these things. However, now you are learning the things, so you may need all these things. So do I need to clarify anything else regarding this cobweb diagram, or it's now okay to all of you?
Yes, ma'am.
Is it okay to all of you?
Yes, ma'am.
Yes, ma'am. Yes.
Yes.
So next, we will consider the time path. Okay. Time path. Here, what is happening to the price? It is oscillatory. However, we are getting damped oscillations. So if I start from this level, the length will continuously fall. Okay, so it is moving up and down the equilibrium as time moves from 1 to up to this direction. Okay, so let me write the things. So if I scale the matter, so time is first period, second period, third period, fourth period. So it is moving like this. Here, this level is basically P. We are plotting PT around T. Okay. So PT can come to up and down the equilibrium. Okay. Up and down the equilibrium. Remember that. So next. Okay, so PE is here. This is a positive value, you know. So if I draw the x-axis, it is like this. Along the x-axis, basically we are measuring time. Time we are measuring. So I may not write T here. I could write T here too if I draw the axis. So this is a specific, you can mark the scale along the horizontal axis to actually, you don't need to draw these parts. However, for giving you the scales, I'm just showing these things to you. These are one, two, etc. 3, 4, etc. Okay. So here we are basically measuring time. This is the equilibrium price, and oscillation takes place around the equilibrium. Generally, in this kind of diagram, we do not add this kind of horizontal axis. Rather, to present the things clearly, we just plot the vertical axis, and then we draw the equilibrium price, and then we consider the movement around the equilibrium. However, there is a horizontal axis, and that horizontal axis is basically measuring the time values, the 1, 2, 3, 4, like this. It is a discrete time, so it is measuring the time component. Okay, could you draw the time path of price? This is the time path. And here we are getting damped. Oscillatory time path. And this is called the Cogwave model. Okay, where equilibrium is dynamically stable. So in this Cogwave, we are getting and I'll go back to the slide. You will find that this is the demand curve. This is the supply curve. This is PE. This is the equilibrium point E. And these are prices at different periods. If you consider these as P1, you will consider this one as P2. If you consider these as P3, this will be considered as P4, and so on. Okay, moving up, moving down. One is up. If one is up, then two is down. If three is up, four is down. So it will be like this. Any question? Is it fine?
Yes, ma'am.
Yes.
Ma'am.
Yes, ma'am.
So this is the diagram. You know, you can do everything. You can extend the price up to the vertical axis. You can extend the quantities up to the horizontal axis, whatever you like. Try to learn the things, draw the things. Okay. And then finally, when you will be really very comfortable with this kind of model, you can present it like this. And this is the damped oscillatory time path of price. Next, naturally, we have to consider when the equilibrium is dynamically unstable. Okay, so here for this particular curve wave, what we are finding that we are moving away and away from the equilibrium. Okay, so should I do this thing too today, or it will be heavy to all of you? Should I draw explosive oscillations? or I'll do it in the next class?
Ma'am, you can
Ma'am,
do it today if possible.
Yes, ma'am. You can do it today.
I'll do it.
Yes,
Yes,
ma'am.
ma'am.
yes, ma'am.
So next, I hope you are understanding. I'll consider the negatively sloped demand, positively sloped supply, beta 1 by beta 2 less than 0 for that matter. Modulus beta 1 by beta 2 is greater than 1 in this case. Modulus beta 1 by beta 2 is greater than 1 in this case. Okay. In the previous case, it was less than 1. Now I'll consider it to be greater than 1. That is the only difference between the two cases. Okay, so first I'm marking the price and the quantity axis, and then I'm drawing the demand curve. Then I'll not draw the supply curve, I'll draw it using back calculation only. Okay, now here I have idea that I'll move away and away from the equilibrium. So here I'm not starting from this point, rather I am drawing something which is in the central position so that I can draw a complete cobweb. So this time what I have done, I have extended this price line beyond the first quantity. Okay, this is the first quantity. I have extended it up to this. In the previous diagram, I stopped here, and now I have extended this up to this. Okay. Once I get these 2 points, first I'll join these 2 points, this point with this point, this point with this point, okay? And then finish the diagram. So it will move on like this. Okay, I'm not making more movement. I'm stopping here and putting an arrow. And as I mentioned, you can put arrows okay. So this is the way. This is the way the things are moving. Okay, so this is the equilibrium price. I hope you could do it. If anyone has any doubt, please ask me. This is O, this is price, this is equilibrium price, this is demand. Okay, this is supply. So all these things are there. And I hope you are understanding this amount is the first quantity. This is the first quantity. Okay. And this is the first price. Okay. Now at this price there is an excess supply. So economic law is telling us price will go down. So price is going down. And when it is going down, the next price is given by this one. Okay, it is coming equilibrium since beta 1 by beta 2 is negative. This price, there is an
Can you please repeat?
This is the quantity, first quantity. Okay.
Yes.
The demand price, and this is the supply price. Okay. This is the, if you drop this thing, this is the supply price. Okay. Or you can say this is the quantity demanded. And if I drop a line, sorry, not this. If I draw a line like this is quantity supplied, this is quantity demanded, this is quantity supplied, and price is given by this one. This is the first price, P1. We are finding excess supply here. Excess supply. Supply is greater than demand. So if there is an excess supply, there will be a reduction in price. So price will reduce. Now when the price is reducing, it is coming to this level. Okay, got it? It is coming to this level. So
Yes,
at this price, this is the supply. The brown one is the supply, whereas the blue one is the demand. So there is an excess supply. This blue line, price line, is indicating there is an excess supply because this is the, there is an excess demand. This is the supply and this is the demand. So there is an excess demand. As there is an excess demand, price will go up. So price is coming to this level. Price is going up and coming to this level. At this price, this is the demand. However, this is the supply. So there is an excess supply. So price will fall down. So it is coming to this level. It is falling down and coming to this level. Okay. Then excess demand, it will go up. So price is moving to this level. Excess supply will go down. So it is moving up, moving down. Why it is moving up and down? Following the excess demand, excess supply principle. Why it is moving around P? Because here beta 1 by beta 2 is negative. So as we consider the even power, it remains above. As we consider the odd power, it goes below. So we are getting this kind of cobweb here, you know. So this is the idea. Now, is it clear to all of you, or you need some more clarification? Could you complete the drawing? This part
Yes,
is
ma'am, it's clear.
Yes, ma'am.
Yes, ma'am.
okay. These parts are optional. You may draw it, or you may drop it. So everything is there. Remember that quantity price mechanism is excess demand, excess supply principle. The new things are moving up, down, because you are considering consecutive periods. Previously, when we discussed about Walrasian and Marshallian static stability conditions, we could not get all these things because, you know, we are not getting periodic fluctuations. We have a single period. So the extra addition is here, extra learning is here. We are getting idea about periodic fluctuations of the economic variable. Okay, so if you understand the things well, next we will consider the time path. Okay, so it is like this, moving up and down and fluctuating. So, as I mentioned, T okay. Actually, these levels are P naughts. This is P naught. So it is changing like this. So it is explosive. Oscillations. And this is
Ma'am, can explosive oscillations ever start from the P point and then move away from it? Is that possible?
no, you have to start from off equilibrium position. The question is whether you can move towards equilibrium or you are moving away from the equilibrium. So it will never start from PE. If it is at PE, it will be at rest because PE is the intertemporal equilibrium. Okay, the entire exercise considers the fact that price is at off equilibrium position, then the question is whether it will move towards the equilibrium or it will not. Okay. So your starting point is off equilibrium starting point, not from equilibrium. If it is at equilibrium, there is no question of getting the time path because it is an intertemporal equilibrium. Over time, the entire situation will remain at equilibrium. Okay. Any question? Any other question for this model? The drawing, etc. Anything? Do I need to repeat any section?
Ma'am, it is clear to me.
So this one is the thing which we have completed. And finally, in this kind of oscillation, this is the last case. And I hope you are understanding here, you have to lock the box. So you have to start from here, come here, and here. Okay, and draw the supply curve joining these 2 points. So the price will move up and down to the equilibrium level. However, the up level is fixed, the down level is fixed. Okay, so it is moving within the band. It is moving within the band. Here, since mod beta 1 by beta 2 is equal to 1, actually, if you consider beta 1 by beta 2 value, it is the -1 value and the +1 value. So basically, this value is the -1 and this value is the +1 value. This is -1, this is +1. So the entire thing will fluctuate at this particular level. And if you draw the time path, it will look like this. Okay. If you look at the length, this length is same to that, same. You know, it is also similar to this one. This is similar to this one. So uniform oscillation. Okay. So it is moving within a band, moving within a band. So we call it uniform oscillations. So do I need to draw this thing or you will be able to draw it on your own?
We will try.
And we can draw it.
So draw it.
Yes, ma'am.
Yes, ma'am.
Okay, so draw it, draw the demand curve. Consider a quantity, mark the price, lock the box, then draw the supply curve. Consider the movements. Done?
Yes,
Yes,
ma'am.
it's done.
Yes, ma'am.
Yes, ma'am.
So equilibrium is dynamically unstable because this is not a stable equilibrium. Though it is uniform, however, it's not coming towards equilibrium. And this is the time path. You can draw the axis if you like, or if you can keep the things like this. Okay. So I'll stop here. Next day, I'll discuss about several monotonic time paths, and then I'll shift to the next application. So today, we practice the oscillatory time paths, So from Chiang, now you start solving the equations for the from the cobweb model section. Okay, for the cobweb model section, you will get the equations. So start solving those equations. And in the meantime, I'll check your 3D. So everything is fine to all of you?
Yes, ma'am.
Yes, ma'am.
Okay.